Hello everyone. So welcome back to my next video on the data frames. In this video we'll continue from the previous video where we have left. In the previous video we have seen when the last thing which we saw was we applied a filter condition, a single filter condition. Now now I'm trying to apply a filter condition with more than filter with more than one condition. So I'm saying remember that the CR is the name of my data frame. So if you see cr dot head, so just a quick revision. So cr dot head, and we can see that I have already read my file. So it contains your. I'm seeing my top 10, top 5 records. If you want, you can see your top 10 records. Uh, so now I want to. So this applicant income, gender, married are the name of the columns. We can see that married, gender, applicant, income are the name of the columns or the name of the features in the data frame. I want to select, I want to pass multiple filter conditions. So applicant income should be greater than equal to some number, gender should be male, person should be married. So if I, so in this CR, so I have run this and I have stored this condition in a variable CA. If you see the variable CA, it will give you the value as true and false. So whichever for each row you will get answer either true or false. So a row, if the condition is met, we get the true, and if the condition is not met, we get a false. Now, if we pass this filter condition within the bracket, we will filter out those people who are satisfying these conditions. So let's do a quick check. So I'm saying applicant income should be more than 1526, gender should be male, and person should be married. So now if we see the gender, male, person is married, and applicant income is more than that particular amount. If I want to do the reverse of that thing, then I can say CR minus. So it's equivalent to your false condition. So wherever this condition is not met, you will see those records being selected. How do I fetch a particular column from the data frame? So basically I can use my dot method. I can say cr dot applicant income, or I can so if you just say cr dot and press tab and applicant income, so it fetches you that column. On this column you can run any of your function. You can say mean, so it will give you the mean of your that particular column. There is another way to fetch a column. So using your square bracket, give the name of that column, but give the name within the quotes. So these are the two ways in which you can fetch the name of your. Check the null values. How do we check the null values in our data frame? To check the null values, we will use is null. So I'm saying CR is the name of my data frame, is null is the function, and then I'm saying the sum. So for each column or for each feature, it will give me the null values. So this gives me an idea that credit history is having your maximum nulls, and then your dependent, then your self-employed is having your next null. If you want to remove all the nulls, you can just say drop NA. But let's fill our null value. So if I want to fill the null values, then I'll say cr.credit history. So now what I have set cr.credit history, which is the name of my column, and I'm saying fill NA 0. So wherever the nulls, I am replacing those nulls with my 0. So if I again run this thing, then I should not get any nulls in my credit history. So we see that I do not get any nulls in my credit history column. Similarly, for each and every column, I can use my fill NA function to replace the nulls from that column. There is another thing, you can directly do your drop NA. So cr equal to cr dot drop NA. Now all the nulls should have been dropped. Just do a quick check. Cr is null dot sum, and now I see that there is no nulls exist. So all of my null values have been renaming the columns. How do I rename the column? So for renaming the columns, I'll use my function. So cr dot one. So this applicant name is my name of the original column which previously existed. Applicant income is the name of the column which I want to create. So I am saying cr1 equal to cr dot rename columns equal to applicant income and applicant. So can you see a difference? So here I am passing a small colon. So my new data frame is created, and if I just say cr1 dot columns, you will see that my column has been renamed. So you can see over here. So this column has been renamed. So the cr dot rename can be used to rename multiple columns at a stretch. So basically what I have to do, I have to first create a dictionary. So I'm saying cr dot rename columns. So let's rename more than one column at a stretch. So let me rename this gender. So I want to give the new name as gender1, right? Gender1, and you need to keep one thing in mind. So let me put one more column and then I'll say okay, gender. Let me get this column. Now let's go. Now, so here I am renaming two columns at a stretch at the same time. So column gender is being renamed as your column gender1. Married is being renamed as your married1. So between your these two, I'm using my colon and I'm using comma after one pair of columns. Between one pair, after one pair, I'm using comma. So if we check columns, we'll see that the gender has been renamed as your gender1 and married has been renamed as your married1. If we check the columns, we'll see one thing, that the name of the columns are not arranged in the alphabetical sequence. So to arrange those things in the alphabetical sequence, I'm saying cr dot reindex and sorted as reindex, but reindex on what? Reindex on your sorted columns. Access equal to point indicates I'm doing some operation on my column side and not on my row side. Now if I check the columns, so basically, so let's say CR1 and CR1, CR1. Now if I check the columns, then you'll see that all the columns have been renamed in your alphabetical order. So basically the applicant income, which was previously occurring in your sixth position, has moved to your first position because it's starting with your alphabet A and then followed by a co-applicant income, then credit history and other things. So the renaming of the column has happened based upon your alphabetical ordering. Another way to rename your column is, instead of using your actual column names, instead of using your actual column name, you can also use your index position. So I'm saying cr dot rename columns, cr column 1, and let's say new name. So my first column was my gender one, because indexing starts from 0. So now I'm giving some new name. This one indicates that I am selecting the index position. I am not giving the actual name of the column, but the index position. Now if we see our columns, we will see a new name appearing. Why new name appearing? Because we have given 1 over here. Had we given 0 over here, so let's say 0 and I say new loan ID. So my name would have been changed according to the based upon. If we want to drop a particular column, how do we drop a particular column? We will use a drop function. So I'll say cr.drop and cr.drop or loan ID access equal to 1 in place equal to. So drop is the name of the function which I'll use to drop a column. Loan ID is the name of the column which I want to drop, or I can say the name as new loan ID because I have recently changed the name. So if I give this name, new name, loan ID, access equal to 1, it indicates that I want to drop the column. I want to do something on the column. In place equal to true, it means drop the column and then save the column in the same data frame. So if we save, so now if I run my head function, then I do not see the first column. So my columns are starting from my new name. How do we sort a data frame? If we want to sort a data frame, we can. So basically, we first will need to identify on what column do you want to sort the data frame. So let's say I want to sort it on a loan amount. So if I want to sort some columns, then I can do it on the using my sort value function, the cr dot sort values, and then I need to give the name of the column, any name on which I wish to sort. So let's say I want to sort it on the basis of your loan amount. So I'll say just this thing, and my data frame gets sorted. If you want, you can store this thing back into your data frame to keep your changes permanent. And now when we see that my data frame has been sorted based upon your loan amount. So the smallest value has gone on the top and it has been sorted in my ascending order. If you want to sort this in descending order, so let's say I want to again sort this, but I want to sort it based upon your descending order. So I do the same thing and comma, press your shift tab, and I see here ascending equal to true. So how did I get this tab? How did I get this bar? I said I I clicked here and press shift tab. So if you press shift tab, a help menu gets open. So from here I can see the options. So the default option is your ascending equal to true. I'll say ascending equal to false. And now when we'll see it has been in your descending order. So the highest value are at your top. It has been sorted in your descending order. Highest value at your top level. Top level. So we can also do the sorting based upon on more than one columns. So let's say I want to sort it based upon the gender and the applicant income, or if we have uh, gender and the applicant income. So basically it will take only one column at a time. So wherever the genders are same, then it will see the applicant income. So if we do cr dot sort values, so applicant income is not defined. So let me see. Okay, so applicant income has been changed to something else. So let me take this column. Okay, and I say loan. So gender. So first females would be coming, and wherever and within the females, it would be saying your loan amount. And we can do, okay. So that makes a thing. So we can do the sorting based upon two columns. Also, let's see our correlation matrix. CORR gives you the correlation matrix. So this representation, the below representation, is known as your correlation matrix. So basically correlation matrix is always a square matrix, and it tells you the relationship between the features. So in this, the diagonal element will always be 1. In any correlation matrix, the diagonal element would always be 1, because when I say this 1, it gives me the correlation between your new name and new name, credit history. It gives me the correlation between your credit history and credit history. So the correlation between any two same variable would always be 1. And one thing to notice here is that the values below and above the diagonals are same. So you can see, so this value is being repeated over here, because this minus 0.05480 is correlation between your credit history and new name, and this is your correlation between your, again the same correlation between your credit history and new name. Similarly, correlation between your new name and dependent, this minus 0.04 is being repeated over here. So values are same below and above your diagonal values. So here I am reading my file once more, because I have made number of changes in my file already. Uh, so it's better to read the file once more. So I'm reading the file, and in this line, if I can put it in the next cell. So I'm trying to replace my categorical data with the numeric data. So if you remember, this gender is the name of the column, and your married is again the name of your column. In gender, there were two values. If you check, so if we quickly want to do the check, so let's check our values. Uh, cr dot gender dot value counts, and we see there are two values. Okay, so we have basically already done this. So if I skip this portion and I say, so there are male and female. Similarly, for your married, we see that it consists of your two things. It consists of your yes and no. So what I want to do, I want to let me, for the logical purpose, let me put this line here. I'll do again. Okay. So for male, I want to mark it as 1, and for female, I want to mark it as 0. For married, wherever the person is not married and his value is no, I want to mark it as 1, and for yes, I want to mark it as 1. No, for yes, for no, I want to mark it as, let's say, 0, and for yes, I want to mark it as 1. Now, when we see our data, we'll see, so in gender column, we can see our ones and zeros, and similarly in your married column, we can see our those things. So, so see, so gender, I am having ones and zeros, and similarly for married, again I am having ones and zeros. Another way to deal with my categorical data is another way to deal with my categorical data is use my dummy categorization. So for, I'll add separate columns for each variable. So let me open an Excel before I explain this thing. So how your dummy variable categorization happens is, um, give me a second. Let me explain uh, what dummy categorization actually means, so that you can relate it in the code. So uh, there is a person. So in gender, either the person can be your male or female, and male. So your first person was male, second was female, third was again male, fourth was again male. So fifth is again female. So this is your original data. Uh, but now if you want to do your dummy variable categorization, so instead of assigning male as 1 and female as 0, or so it doesn't matter whether I'm marking male as 1 or female as 0, so vice versa I could have said male as 0 and your female as 1, male as 0 and female as 1, because these 1 and 0 are just a number. So it doesn't so here it does not mean that your 1 is more than 0 or 0 is less than 1. It's just a number because my machine understands a number, so I'm just trying to overcome. So this was the thing which we have done in a previous step. uh, Now if you want to do a dummy categorization, 1 and 0 would be used to indicate the presence. So in previous example, for male and female, I have indicated 1 and 0 and I had only one column. But in dummy variable categorization, I'll have two columns. So these five people would be represented something like this. So the first person was male, I'll say 1 over here and 0 over here. Why 1 over here? Because 1 indicates the presence. Second person was female, so I'll say 0 over here and 1 over here. Third person was male, so I'll say 1 as here and 0 over here. Because 1 indicates the presence and 0 indicates your absence. So I have added two columns. So here 1 and then again 0 over here. For last person was your female, so 0 over here and 1 for here. So this is one thing. Another example. So let's say you have more than two categories. So property area was having three categories. So it was having your urban, rural, and semi-urban. So let's say again your rural, semi-urban. So since you are having three categories, three columns would be added. So if this is your original data, after your dummy categorization, you would be having this. So the first observation was used, so I'll say 1 over here and 0 and 0 over here. Second was R, so I'll say 1 over here and 0, 0 over here. So just we need to keep one thing in mind, that 1 indicates the presence and 0 indicates your absence. So this is SM, so I'll say 0, 0 and 1 over here. And this is R, so I'll say 1 over here and 0 and 0 over here. SM, so SM is your 0 and this is 0 and this is 1. Okay. So basically your numbers of columns will increase in your dummy categorization. Now let's do a dummy variable categorization. So here I am again reading my file once more because I have made a number of changes. So it's better to read my file once more. So in this line I'm reading my file and I'm saying pd.getDummies. So this function getDummies function is coming from your pandas. Remember, import pandas as pd, and this cr is the name of my data frame. I want to do my dummy variable categorization on which columns, on which variables I want to do. I want to do it on my gender, married, dependent, education. Remember, these are the columns which are already present in my data frame. So once I do this, so you will see then the columns getting added. Now you are getting two columns, male, gender female and male. For married you are having two columns, married no, married yes. And similarly for your dependents, dependent 0, 1, 2. And for education, so for education again you are getting graduate and all those columns. So it has added the new columns and it has already removed your previous column. So no more a gender column exists because you have already created two separate columns for it. So this type of representation is known as your dummy variable categorization. Now, if you run your shape function on this, you will see the number of columns have increased. Previously, my data frame was having just 13 columns. Now, the number of columns have increased to your 20, but your number of rows are still the same. Now, let's see our group by function. So again, I'm reading my file fresh. So let me run this thing. So group by function. So CR is the name of my data frame. Group by, I want to group my output on based upon some column. And remember, this column should be your categorical column. You cannot pass a numeric and continuous column. So when I say categorical column, so basically like for example your gender, married, all those things, property status, property area, because they are having just 2 categories, 3 categories, 4 categories. So I am grouping them, the applicant income. So the output here is 4458 for female and 5256 for female. So I want, my aim is to find the mean of the applicant income separately for males and females. So I did the grouping based upon the gender, which is my categorical column, and ran a mathematical operation on my non-categorical column. Then extension of group by. So in this previous example, we have just found the mean. Similarly, I can find the count, min, max, and mean. So to find all those things, I have said .agg. Here this agg stands for your aggregate. So group based upon a categorical column, run the mathematical operations on your numeric and continuous data. So if we see, we can find that applicant income is not a categorical data, it's a numeric data. Another way in which we can run our group by is this. I am grouping it based upon a categorical column, but I want the count, min, max, mean for all the columns. So basically in this, I am not passing any applicant income. So when I pass a particular column, it returns me the output only for that particular column. Here I'm not passing any column. It gives me the output for each and every column. Crosstab. So I am building a cross-functional relationship between my two categorical columns, which are my gender and the loan status. So how do I read this table? So this 55 represents there were 55 females whose loan was not approved or was in status N. 127, there were 127 females whose loans were approved. 207, but the number of males whose loan were not approved. 568 females 568 males whose loans were approved. This crosstab can also be used for your preparing your confusion matrix, which is used to judge your classification model. Though there are a number of other ways in which we can build a confusion matrix, which we'll see later on. Let's see another way, a third way to rename our columns. So let me first read my file. So I have read my file, and then so let me explain this code. So cr1 dot, and just want to see the top two rows. So in gender, either you are having your male or female. So let me say 20 records. So you are having either male or female. Now I want to rename this male with 0 and female with 1, and at the same time I also want to add another column whose name should be label 1. So if I do this thing and then say cr1 dot head, then I'll see a new column has been added, label 1. So wherever you have your male, it is marked as 0, and wherever you have female, it has been marked as 1. So let's compare this. So my this record, the 17th record is female, and you will see that 17th record is having your, so if you see your this thing, 17th record, yeah, so you have your 1 over here. So remember this thing here, I am not removing the original column. The original column gender is still retained. So I can still see my original column gender being retained and adding a new column, that is your label 1. Label 1 has been added. Wherever you had male, it has been marked as 0. Wherever you had female, it has been marked as 1. So this is another way to rename your column. We have already seen how to drop our null values. If you want to drop your duplicates, so the thing would be your drop duplicates and store it. Your duplicates would be removed. This is how we remove the duplicates. So let's check the shape. Uh, So the shape is still same. Probably there are no duplicates, but if any duplicates exist, your cr underscore drop duplicates will remove the duplicates. Selecting the rows and columns using the indexing method, or I can also say this as slicing and dicing of my data frame. Uh, if I want to select the top 5 rows, or if I want to select top 10 rows, I'll use my square bracket, but I cannot directly use my square bracket. I have to say dot iloc. So this I stands for your index and loc stands for your location. So index location. So what's your index location? I say 0:10. That's it. So it will select me top 10 records. So in Python, indexing starts from 0. So 0 and 10. So it will go till 10, but will not include your 10. Now if I want, so here I am selecting top 10 rows, and all columns. If you want to select top 10 rows and first 5 columns, now my aim is to select top 10 rows and first 5 columns. So I want to select loan ID, gender, married, dependent, and education, because these are my first 5 columns. So my code should be something like this. So I'll say rows and comma 0, 1, 2, 3, 4. So this will give me top 10 rows and first 5 columns. Now the what mistake people make is so people may say, okay, I want to select the first 5 rows, so they will say 0, 5. So this will give you an error. Why error? Because now this is kind of sequence. I cannot give it in a list. So this is why you will get an error. So to overcome this error, just say like this. So again, we get the same thing. So keep one thing in mind when you are saying 0, 1, 2, 3, 4, basically you are creating a kind of a list. And when you're using your colon, it's a kind of your sequence, right? So this was your based upon this thing. And similarly, if I want to select if I do not want to select all the rows, but I want to select the some selected few rows, so let's put the problem statement first. I want to select the first row, I want to select the third row, I want to select the fifth row, and all columns. And what should be my code? Cr is the name of my data frame. iloc indicates your index location. I want to select my first row, third row, and fifth row. I'll say bracket open. So when I want to select the first row, I'll say 0 because indexing starts from 0. For 3, I'll write 2. For 5, I'll write 4 and comma. So it selects me 0, comma 2, comma. So I'm selecting that rows and all the columns. Columns and can also be selected based upon your name of the columns. Remember, in these examples, when I'm selecting the columns, I'm passing the position of the column and I'm not passing the actual name of the column, but you can also select the name of the column using your column names. For that, you do not need to use your iloc function, but you need to use your loc function. Using your loc function, I say cr.log gender applicant income. So only two columns, gender and applicant incomes, are selected and all the rows are selected. So you can also select based upon your column names. Uh, Now let's see how to find the percentile for any particular column. So I'm reading my file once more, and uh, I'll use my percentile function. So let me type this out. Uh, let's say cr percentile. So let me explain this output and how this code is working. So percentile we know will go from 0 and it will go till 100. So here 0 is indicate 0.0 is indicating your 0 and this 1 is indicating your almost your 100 percentile. CR is the name of my data frame and applicant income is a column within my data frame. Describe and percentile. So the output is count 981 and this thing. So let's see from here. So what is this 2221000 means? So it means there are 10% of the people who are earning less than or equal to 2221, 50%. So this means there are 50% of the people who are earning less than or equal to 3800. There are 90% people who are earning less than 8750. All the people are earning between your less than or equal to your 81,000. So here we actually see what in the real life we we are actually also told that uh, the rich people hold the maximum amount of the wealth. So we can see that max 90% of the people are falling with less than or equal to 8,750 and only 10% is more than that. If we want to further look into it, we can say we can still break this down, and if I see my 0.95 percentile, so in 0.95 percentile, so do you see that 95% of the people are earning less than or equal to 12,500, only 5% of the people are earning more than 12,500. So basically, when in a percentile, so if 60%, this means your 60% of the people are earning less than or equal to 4,301. So, a very important thing, or I'll say a very important feature, one of them. So when I just say CR or print CR, it shows me the all the rows and all the it tries to show me all the rows and all the columns. But if your data is very big, so let's say you have 50-60 columns in your data frame, then it may not show you all the columns. Similarly, it may not show you all the rows. For example, so after 29 it's putting your dot 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 dot, it's not printing all the column. It doesn't mean that all these rows or columns do not exist. Just because of the space issue over here, it's not printing you all the rows, but these rows exist. If you want to see all the rows in your Jupyter notebook, you have to add an option display max row. Now, if I run this and I see this, then you will not face that problem. So it may take some while because it's printing all the rows. Now, if you see this, hold on. Now, if you see this, it's not giving dot 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 after 29. It's showing you all the rows without any break. Similarly, if you have many columns and your all columns are not getting displayed, instead of saying max rows, you can say max columns. So it will show you all the columns without putting those dot dot dots and omitting those columns. Pretty much covers almost all the things needed on the Pandas side to clean and prepare our data. So we just do a brush up. What all things we have done. First of all, we saw how to read our files and how to get familiar with our data, head, tail, describe function, and then we have seen multiple ways to rename our data, select the numerical and categorical values. Then we have seen how to apply our filter conditions, um, see our filter condition, how to drop our nulls, how to drop our duplicate values. So it covers pretty much all the things needed on the data frame side. I'm quite sure you liked my videos, and if yes, you did like my video, please click on the like button and also on the subscribe button. Hope to see you soon in my next video. Till the time, happy learning.